In this video, I will evaluate the sine and cosine functions of a sum or difference, cosine x plus minus y and sine x plus minus y. First, let's look at Euler's formula here. E to the power of ix equals cosine x plus I times sine x. Using this formula, we get cosine x equals e to the power of ix plus e to the power of negative ix over 2. And the sine x equals e to the power of ix minus e to the power of negative ix over 2i. Now we expand this cosine x plus y. This is e to the power of I times x plus y plus e to the power of negative I x plus y over 2. And right here, this is just the product of e to the power of ix and e to the power of iy. And over here, this is the product of e to the power of negative ix and e to the power of negative iy. And we have 2 terms times 2 terms. We have 4 terms here. And over here, we have also 4 terms. Over here, we have 2 real terms, 2 imaginary terms. Same here, 2 real terms, 2 imaginary terms. Fortunately, if you look at the imaginary terms, over here, the 2 imaginary terms and these 2 imaginary terms are exactly the same, but with opposite signs. Therefore, they cancel. How about the real terms? The real terms are cosine x, cosine y minus sine x, sine y here. How about this one? Same thing. Therefore, the result is simple. Cosine x times cosine y minus sine x, sine y is equal to cosine x plus y. So now let's change the sign of y. So we basically just replace positive y with negative y. And then we just replace this with negative y, replace this with negative y. Cosine functions are even functions, therefore cosine negative y is just cosine y. But sine negative y is negative sine y because sine functions are odd functions. Therefore, the result of cosine x minus y is cosine x times cosine y plus sine x times sine y. You can verify this by setting x equals y. And then you have cosine 0. Cosine 0 is 1. And over here, you have cosine x squared plus sine x squared, which is 1. So you just verify this. How about cosine 2x? Well, you just replace this y with x. And then you have cosine x squared minus sine x squared. That's it. And then because cosine x squared plus sine x squared is 1, so we can also write this cosine 2x equals 1 minus 2 sine x squared, or 2 cosine x squared minus 1. How about the sine function? Sine x plus y equals, over here, e to the power of I times x plus y minus e to the power of negative I x plus y over 2i. And then similarly, we expand this to be e to the power of ix, e to the power of iy, over here e to the power of negative ix, e to the power of negative iy. And again, we have 2 real terms, 2 imaginary terms here. Also, we have 2 real terms and 2 imaginary terms here. In this case, the 2 real terms here cancel the 2 real terms here. So we have only imaginary terms. What are the imaginary terms? So it's I times sine x times cosine y here, and I times cosine x times sine y here. So we have an I here. And also same here, but we have a minus sign here and again a minus sign here. So it becomes positive I times cosine x times sine y plus sine x times cosine y. And this part is equal to this part. Therefore, the result is simple. Sine x plus y equals sine x cosine y plus cosine x sine y. What about sine x minus y? Just replace this y with negative y, and then we get sine x cosine y minus cosine x sine y. Again, this is because cosine functions are even functions. Sine functions are odd functions. How about sine 2x? Very simple. Replace this y with x. The result is 2 sine x cosine x. Also, we can verify this by setting x equals y. And then you get sine 0. Over here, you have sine x times cosine x minus cosine x times sine x. You also get 0. So this is verified numerically for the x equals y case.